These questions don't show up that frequently, but you need to be ready for them when they do. I'm Erika with Target Test Prep, and today I'm going to teach you how to solve 9 uncommon GMAT question types. Let's jump in. Our first uncommon question type is symbolism questions. Symbolism questions tend to freak test takers out the first time they see them because they feature mathematical symbols that they've never seen before. And when you see something you've never seen before on a test, that's typically something you freak out about. But the secret to symbolism questions is that they're just function questions in disguise. The symbol defines a function with recognizable mathematical operations that you can apply to different values. Once you know that, these problems can be approached in the exact same way you'd approach function questions, with basic plug and chug. In the case of nested functions, it's as simple as working from the inside out, taking one symbol operation at a time, applying the result to the next layer of operations, and repeating the process until you reach the outside. Our next uncommon question type is complete the passage. Like symbolism questions, complete the passage questions can be alarming to test takers because they have a very striking visual appearance. Why is there a blank in this critical reasoning argument? What is this question type? What strategies do I use? And the thing to know here is that complete the passage isn't really its own question type. It's a unique presentation of other, more familiar question types. The trick is to identify what question type we're dealing with by determining what role the blank fills in the passage. Is it the conclusion of the passage? Then it's an inference question. Is it a premise? Then it's a strengthened question. Is it surrounded by contrast language and transition words? Good chance it's a weakened question. Once we have the question type pegged, we can approach as we normally would a question of that type. Next up is permutation with indistinguishable items. Permutation questions are already pretty rare, so appearances of a variant like permutation with indistinguishable items are going to be pretty few and far between. But what makes this question type extremely annoying is that it works completely differently from regular permutations. When a permutation scenario features indistinguishable items, the fundamental counting principle we normally use will not work. The standard permutations equation also will not work. The way to solve these is, unfortunately, to memorize a new equation. Fortunately, it's a pretty easy one. The factorial of the total number of items over the product of the factorials of the count of each type of indistinguishable item. Now, like any other permutation problem, we need to correctly interpret and consider any restrictions in the scenario, but from there, it's simple arithmetic. Our fourth uncommon question type is parallel reasoning. Parallel reasoning questions do appear in official GMAT materials, so it's worth being ready for them. That said, these questions are so uncommon that I gave up on finding a good example question after spending quite some time digging for one. But that's okay, because it gives me a chance to illustrate the truth of these questions, which is that they're just regular old method of reasoning questions like this one, plus a layer of abstraction. So in a method of reasoning question, we break down the structure of the argument and then find an answer choice that outlines that structure. In a parallel reasoning question, it's the same thing, but plus an extra step, because the correct answer choice instead mirrors the structure in a new, unrelated argument, like the invented example you see here, while the incorrect answers will feature arguments with different structures. This means that to find the correct answer, we need to repeat the process of breaking down the argument structure for each of the answer choices to find the one that matches the structure of the passage. Time-consuming? Yes, but nothing we haven't seen before. Our fifth uncommon question type is systems of inequalities. I'm going to be honest, I didn't completely understand how to solve systems of inequalities questions until I was well into my test prep teaching career. And it's true that you can often test numbers and process of elimination your way to success on these questions. However, there is a much more effective approach. When we have a system of equations, we can approach with either substitution or elimination. Now, substitution doesn't work for inequalities because quantities must be equal in order to substitute them for one another. But elimination is fair game, so long as our signs match. This means that we can manipulate our inequalities as needed, being careful with our signs, such that adding or subtracting the inequalities will eliminate a variable, thus allowing us to solve for the other variable. Another uncommon question type is critical reasoning on reading comprehension. These surprised me the first time I saw them. Most critical reasoning questions are paired with classic critical reasoning passages, short arguments tied to a single question. However, occasionally you get a classic critical reasoning question, strengthen, weaken, assumption, etc., on one of the longer multi-question reading comprehension passages. Luckily, these don't require much additional preparation beyond awareness. Once we know to look out for these, we can correctly identify the question type and bring our critical reasoning strategies to bear on the longer passage, typically by narrowing in on the part of the passage that the question refers to, identifying premises and conclusions, and approaching as normal. Next is matching probability questions. Let me define this first. Matching probability questions ask test takers to determine the likelihood of selecting a matching set of two or more items. Now, when a problem specifies the type of matching set it's looking for, so a specific number on dice, a specific color in socks, that's going to be a standard probability problem. Where it gets weird is when the question doesn't specify which type of matching set it's looking for, just that it matches. Now, some of these problems can be solved by calculating the probability of each of these favorable sets and adding them together, or by finding the number of favorable sets and dividing by the total number of possible sets. But a more effective solution is recognizing that this is just dependent probability where the first pick in a set can be anything. Thus, the probability is 1. Now, once that first pick is locked in, our probability narrows, and we multiply by the probability of the subsequent pick or picks matching it, considering any further restrictions and whether we are not replacing and repeating as necessary. As an aside, it's no coincidence that 2 of these problems have fallen into the probability, permutations, and combinations camp. There are a lot of weird variations of these questions, but many of them can be handled pretty simply. Check out my video on an unexpected tip for permutations, combinations, and probability for a secret tactic on solving problems that seem impossible. Question type number 8 is the not except question. Not except is, again, more of a unique presentation than a specific question type. Not except questions show up most frequently across question types in reading comprehension and critical reasoning, but you should be prepared for them to show up elsewhere on the test as well. Not except questions ask test takers to pick the answer that does not match a certain specification. There are 2 tricks to getting these right. First, embrace process of elimination. You'll typically answer these by eliminating all of the answers that do meet the specification in the question stem, leaving you with the answer that doesn't. Second, ensure you don't accidentally answer the opposite question. It is extremely common that test takers go on autopilot and pick an answer that matches the specification rather than eliminating it. To avoid this, write down the word not or except with a huge circle or multiple arrows and confirm before submitting. Does my answer choice make sense with the question being asked? Now, if you weren't sure what I was doing with all of the nots in that question, check out my 3 levels of assumption questions video to learn more about the negation strategy, as well as when and how to successfully deploy it. Our 9th and final uncommon question type is Roman numerals questions. Another question presentation, this time quant-focused. Roman numerals questions present various statements, designated with Roman numerals, which may or may not be true, which we then must evaluate. Again, I have 2 tricks for these. First, read carefully. Does this say must be true or could be true? This tiny tweak in language can completely change your answer, so look alive. Second, know that these are a lot like data sufficiency, in that we are evaluating whether we have enough information to come to certain conclusions 100% of the time. This similarity means that a lot of the strategies we use on data sufficiency can come in handy here. Working with the information we've been given in our question stem before jumping into evaluating. Thinking about how edge cases like number properties and extremes can impact the relationships present, and eliminating answer choices as we go to reduce work as well as to help us make an educated guess if needed. Now, this list is not exhaustive, so let us know in the comments if there are any other weird question types you'd like us to make a video on. In the meantime, like this video if it helped you and subscribe to our channel for more helpful tips and tricks. Thanks for watching, and I'll see you in the next one.